Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge. The problem is concatenation of consecutive binary numbers, and the problem is the given an integer n, return the decimal value of the binary string formed by concatenating the binary representations of 1 to n in order. So modulo we should give the answer in modulo 10 power 9 plus 7. So we can try run the example to get a better understanding. If n is 1, the concatenated binary string is also 1, answer is 1. Why so? The binary of 1 is 1 and its decimal value is 1. We can go for n equal to 3. For 1, the binary representation is 1. For 2, the binary representation is 1 0. For 3, the binary representation is 1 1. So finally, if we append all the things, it will become 1 1 0 1 1, and its decimal value is 27. This is the decimal value of this binary number, so the decimal value is 27 and we have to return this answer. So this is quite simple for understanding. For we have to append all the binary numbers from 1 to n and we have to form the decimal number, which is our resultant answer. So how can we solve this approach, solve this problem? First we can do a brute force itself. What will be the brute force? What will be the constraints first? The constraints is 10 power 5, so it is quite large. So for converting of a single number into a binary representation, it is an order of log n. So the brute force, what we will be doing is, we will run a for loop from I starting from 1 to n. For each and everything, we will be getting this. We can first form a string which is going to have this resultant binary representation. So what I will do is, I will append the get binary of this I is nothing but the integer 1 to n, and this get binary is going to return me a string, converted binary string. Get binary returns me the converted binary string of I. So here the time complexity will be order of log n, and for this for loop will be an order of n. This for loop will be an order of n, and after which this is nothing but this for loop, and this log n will be an order of n log n. But since the constraint is quite large, we may end up, since it is a 10 power 5, we may form a string which is very large. For we can take an example. If we are giving the 10 power 5 itself as the input, we will be forming a string which is of length more than 10 power 9, maybe, because we will be forming a binary string for 1 2, then 3, and then 4, then 5, then 6, and this will lead to a very longer string, and when we pass that string, it will be definitely give a TLE. Why so? I guess it will give a TLE. Let us try this code and then we will see for the optimization. Quickly we can try this code and then we can go for the optimization. So it will be more easy because I didn't get some idea. What I'm going to do is, I will be traversing this n in the range 1 till n I plus plus. Now what I will be doing is, I have to form the binary string. What first I will have a string variable. The string yes, in this s plus equal to, what I will be doing is, get binary. I will call this function and I will pass I, and after which I will have a long answer, and I will convert binary to decimal. This function is, when I will pass the string yes, this will convert and give us a decimal answer, and finally return this answer mod value. What is the mod value? Const int mod equal to 1 1e9 plus 7. Super. So now what I can do is I can just define those functions alone. It will be more easy. This get binary is going to return me a string get binary of I of a int n. This get binary, first I want to have a string yes, and while my n is greater than 0, if my n ampersand 1, sorry, you have to append zeros and 1 as well. So yes plus equal to string of n ampersand 1, and n will be shifted left right once, after which I have to reverse. I will be forming a reversed binary string. So for that I can just use this reverse SPL this dot in. If you follow this, you may understand what I'm doing. After reversing, I will return this yes. So this will give me the binary string. Superb. If you need, I can just I have to declare. Okay, no, not an issue. So now what I can do is I have to define this function convert binary. This is going to return me a long answer. Convert binary to decimal. The input that it takes is a string value. To convert a binary string, it is very easy. How we can convert a binary string into a decimal? If we have 101, this 1 is raised to 2 power 0. This 0, if it is a 0, we are not going to add in our answer. And this 1 is raised to 2 power 2. So for each and every time 2 is getting on multiplied. So what I can do is I can first have a long multiply which is initially 1. Whenever I pass the string, I will get the size of the string in just size. Now I want to come from in reverse of that string in I equal to n minus 1, I greater than or equal to 0, I minus. Whenever I come inside, I'm going to add it to our answer. I will have a long answer as well, which is initialized to 0, and finally I'm going to return this answer only. So what I'm doing is this is raised to 1. Initially I am having a 0 answer. 2 power 0 1, since this is 1, so it will be added to our answer plus equal to 2 power 0. 2 power 0 is nothing but 1. Now my answer is 1. Now this since it is a 0, I am not adding anything. Since this is a 1, it will be 2 power 2. Next is 2 power 0, then here 2 power 1, then here it is 2 power 2. So 2 power 2 answer plus equal to 2 power 2, which is 4. So answer will become 5. And which is our decimal value for this 101. So what I can do is from reverse I'm coming. I am just multiplying it by 2. Multiplier star equal to 2. But since initially this is 1, if it gets multiplied by 2, then it will become 2, and directly I am going to add this 2 in for this first decimal. It should not happen. If I initialize this multiplier to 0, then multiplier into 2 will become again 0. For the next iteration also it will become 0. For the again the next iteration it will become 0. So what I can do is, for a clear way, I can start from the last before index. And what I can do for that, I can just do n minus 2, and if my s of I is equal to a 1, then I will be adding it to my answer plus equal to multiplier, as simple as that. And then what finally, if my answer, or initially itself, if my last index is 1, then I can initialize answer to be 1. If my s of n minus 1, which is my last index. If it is 1, I can initialize answer to be 1, or else it should be initialized with 0. I hope you get the understanding. I'm not very complicating it. Yeah, I cannot initialize this multiplier to 0 because each and every time I'm going to multiply this, each and every time this is raised once, this is multiplied by 2 once, so that only in the iteration itself I am multiplying it by 2. That's it. So now let us try to run the code and see. Okay, it gets accepted, but I don't think so it will get accepted in our solution, because this will be an order of n into order of log n, but the string that we are forming is going to be very large. Let us have the input as 10 power 5. If this is 10 power 5, we are getting a correct answer or not? No, we are getting a wrong runtime error. Why so? It is whenever this multiplier is multiplied by 2, it is going to give us a large number. So what we can cleverly do is we can have a mod value that is going to mod this 1 9 plus 7. We can just multiplier mod equals to mod. That's it. So that it will be having an integer value itself whenever it is multiplied by 2. Yeah, we get correct answer, but this will be a very time consuming. As you can see, the time to 78 milliseconds for that one test case. We can give submit. Definitely we will get a TLE, I guess, because the string formed was very large. Yeah, we got TLE. So how we can optimize this? Let us think a little bit. What we are doing is, we want to form the entire string, or else we cannot do it. So if I can reduce this part, then I can definitely get an accepted, because this is going to be an order of n into log n only. So what I can do is, on the run, what I'm actually doing is, I'm going for this n equal to 3, I'm forming the string first 1 1 0 1 1, and then I'm converting this to a decimal value. So as you can see this, as you can split and see, this is nothing but 1 1 0 then 1 1. So it is nothing but 3 then 2 then 1. In coming in reverse fashion, if I can convert this decimal on the go in this iteration, then it will be very easier to reduce the time complexity to order of n into log n. That is, for this 1 it is going to raise it to 2 power 0, for this 1 it is going to raise 2 power 1, for this 0 will be getting 2 power 2, and then for this 1 it is going to be 2 power 3. Like this, I can on the go, I can just convert our answer. We can form our answer. So that what we can do is, first we can take this part. Definitely I'm going to need this answer, long answer and multiplier. I can delete this part. This part is going to give us a TLE. So first I have to convert this into in reverse fashion. So int I equal to n minus 1, sorry, n I greater than or equal to 1, I greater than or equal to 1, I minus minus. Whenever I come inside this loop, I just have a variable 1. I just take this temporary variable int k. While k is greater than 0, I want to convert this into convert this a decimal value. I know one condition, that if my k ampersand 1 is 1, then I will be adding it to my answer plus equal to multiplier, and for each and every time this k is right shifted by once. This is done, but how we are going to handle this case? I know that we are going to handle that last case, right? Because this last value we cannot do, because multiplier is will be multiplied by 2. Multiplier star equals to 2, then multiplier mod equals to this mod value. This one we are going to do. You just think a little bit. Now my int I equal to n is nothing but 3, so k becomes 3. Now while k is greater than 0, 3 is greater than 0, then my multiplier is going to multiply it by 2. But for my multiplier is now 2, mul value is now 2, and the last bit is also set. Then we will tend to add this 2 into our answer, but this is not true, right? It should not be true. So what I can do is I can initially have this multiplier as 0, and I can also have a flag variable bool flag initially false, and another one initially false. This one for what? If this is if the last bit is set to 1, I'm going to add it to my answer in last. Answer plus equal to 1. What I'm going to do is I'm just adding one this is one time process, so I can have this flag variable and do it. What I will be doing is, if my flag is not set, then this is the first time I'm going to enter it. So what I will be doing is I will initialize this multiplier to be 1. Then what I will be doing is I will make this flag to be true. Then I want to make this one flag. I want to make this one flag also be true if this last bit is 1. So if my k ampersand 1 is true, then I will make this one flag to be true. So this is a one-time process, and then this can be an else part. That's it. And each and every time k will be shifted once, right? That's it. And then multiplier will be multiplied. Okay, yes, I will give a clear understanding what I'm doing. Just I will eliminate these codes as well. We are having this flag variable because I have to have the last bit value to be accounted. So what I'm doing is, each and every time I'm coming in a reverse fashion, where initially the flag is false, so this condition will be executed at first, and then I will set this multiplier to be 1, and then flag is true, so that from the next iteration this if condition will not be executed anytime. And then if my last bit is set 1, then I will set this one flag to be true, so that finally I will add it to my answer plus equal to 1. Else this if condition will not be executed anytime, and then if that kth bit k ampersand 1 is 1, then I will add this answer multiplier it to my answer. That's it. And each and every time I will be right shifting this k, and this is definitely n into or log n, so which is order of n into log n. So this should run. Let us try to run the code. Okay, I have missed some semicolon here. Else where I missed after expression. Sorry, actually it is else if, right? I have missed this else if. Now it should be running fine. Else if my k is set to 1, then I will be adding it to my answer. Okay, I will run this wrong test case as well. If this is getting executed, this should definitely get accepted. It is accepting. We can give a loose value 10 power 5. Superb, it gets accepted. Now let us submit the code. Superb, it got accepted. Hope you like this solution and let me know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.